Ladies and gentlemen, welcome to our second video on the road from rookie to mastering calculus. And this was the theorem we had the previous time, and there were two statements we made, and we're going to be talking about this one today, a bit more precise, and then we'll have this. So let's jump straight into this one. If the greatest power of the numerator is greater than the greatest power of the denominator, then the limit of that function where x approaches infinity will be equal to infinity itself. Or this actually means that the function of x is limitless, which means that it actually doesn't have a limit, and we write this as this, that the limit is equal to infinity. So let's see what that means. Okay, this is some bullshit here, so let's get straight into a limit where x approaches infinity of, let's say, 2x to the power of 5 minus 7 divided by x to the power of 4 plus 3x squared minus 7. Let's take minus 7 too. Okay, this means that if we take a limit where x approaches infinity, we must divide this expression, or we must divide this expression with the greatest power of x in the denominator. That was a mistake I probably made in the previous video. You have to divide by the greatest power of the denominator, not of the whole term, because if you would go and divide by x to the power of 5, we would get a 0 in the denominator, and we don't know how to tackle those problems yet, so we have to go and divide by the greatest power of the denominator, which means that this case is x on 4. So we extract x to the power of 4, and we get 2x minus 7 all divided by x4 extracted 1 plus 3, and we get x squared divided by x to the power of 4, which is x and minus 2, and then minus 7 x and minus 4. Of course, x minus 1 is equal to this. And let's change some colors to the yellow, and the x on 4 cancels out, so we get the limit where x approaches infinity of 2x minus 7 divided by this stuff here, and we can see that these 3x minus 2 and minus 7x on minus 4 actually cancels out, because the greater the x gets, it gets close to infinity, the greater the denominator is, and as we said in the previous video, this is equal to 0. So we got 1 plus 0, which is 1. And this means that the limit, this is equal to the limit where x approaches infinity of 2x minus 7. I'll be right back, I'm sorry. Oh, I'm sorry, somebody was ringing the phone, on the phone at the doors, so I had to go and open. It was my mom. And yes, the limit actually equals to this, and if we graph this, this would look like something like this. If there is minus 7, this would go something like this. And as you can see, the graph is not limited. The function is not limited, it is limitless. And you write this, that as x approaches infinity, the limit of that function equals infinity. And this is exactly what we have set here, that the limit of f of x is equal to a infinity if f of x is limitless. Let's go back, and now let's take another example of the one that the power in the numerator is the same as the power in the denominator. So let's go limit and let's go with one hard one. So limit as x approaches infinity of 5x on 4 plus 3x cubed minus 2x squared plus 7. Actually, it doesn't matter how hard it is. It is not measured by the terms in it, and so let's make this a bit more quickly. So you have like 2x on 4 minus 3. So as we can see, the powers are the same. We extract the x on power 4 because that is the greatest value in the denominator, and we have a a limit where x approaches infinity of x on power 4 like this of 5 plus 3x cubed x4 minus 2x squared divided by x4 plus 7 divided by x4, and we have x4 also here, and we have 2 minus 3 divided by x in power 4. And as we know, as x is approaching infinity, all these terms that have a greater value of x than in the numerator, they all cancel out. This term cancels out because it gets to 0 as x is going to infinity, as we have proved a zillion times already. This one cancels out, and this one cancels out, and this x on power 4 and this one also cancel out because they're the same. And oh, I'm sorry, we are missing parentheses here, and read again, and this one also cancels out. So what stays? What stays is, we can say that this is 5 divided by 2. We don't need the limit anymore because the x's are not involved anymore. So the limit of this whole expression is equal to 5 over 2. And as we said, it is greater than 0, which is good because that is what we have found out. And there is another small thing I'd like to mention, which is very useful, that when the powers in the numerator and denominator are the same, the greatest of course, we can actually calculate the limit out pretty fast. We just take the numbers in front of that x on the greatest power, which in this case is 5, and this 5 is right here, and this 2 is right here. So that's the fastest way on how to find out a limit where there are x on the same power in the numerator and denominator. So this can be written as this. Let's check this one, and let's write this down like the second theorem. This could be a theorem, it's not an official theorem, I don't know, but the second theorem could be a limit where x approaches infinity of a x on n, there can be plus, it doesn't matter what, divided by b x on n plus whatever, where x on n is the greatest power of x, actually n being the greatest power of x. The limit is equal to a divided by b. So that is our second statement. It is not a theorem, so we won't, let's call not a theorem. I don't know if it's official theorem or not. I've actually figured out myself. I'm a self-learner in calculus, if you don't know. So this is it. This is our next thing that we are good to remember. So I think this will be for this video, and I think we have covered the limits to infinity pretty well, and there are some more theorems for the next video, and then we'll go to the limits at 0 and any other certain value. So I hope you enjoyed, hope you learned something new. Check out the previous video if you haven't, if you were a bit of confused, and I advise you that you take a look at the videos from the beginning onwards, because that is actually the only way you're going to be able to follow them. I'm sorry, because this is going to be like a long story. I said the path from rookie to mastering calculus. So next time we'll be figuring out a limits at infinity and at certain values and some more theorems.